Hello Internet, my name is Quinn and this is Blondihacks. I'm back on the Pennsylvania A3 switcher locomotive build this week and I'm going to make the tender stairs. This is a utility set of stairs for the crew to access the water hatch and to get back and forth over the tender without having to get off the equipment. Now it's just a folded sheet of metal. How hard could that be, right? Ooh, buckle up, sit down and shut up and let's go. Well, that seemed unnecessarily aggressive. Anyway, here's the tender where we left it last time. The next thing I'm going to do is add the staircase that goes down the back of the slope right here. On the HO scale model, you can see that staircase right here to give you a sense of what we're going to be building. Now what's interesting is that this staircase is not fully enclosed. The treads are actually open, as you can see here on the prototype. It's a little bit hard to get photographs of the real thing. All the ones that are available aren't very good, but you can see the staircase back here. Here's a different photograph that'll show it a little bit better. You can see that these stairs are really an open piece of sheet metal that's just been bent into shape and riveted onto the deck. So that's what we're going to do. Might look primitive, but that's how the real thing is. It's going to be one long piece of brass bent into shape with a lot of complicated bends, 21 bends I think in total. I'm actually going to prepare 2 blanks for this because due to the complexity of all the bending, I'm pretty sure I'm going to screw one of them up, so I'm going to prepare a backup just in case. After rough cutting on the bandsaw, then of course I take it over to my sheet metal milling setup and clean up all the edges, bring everything down to dimension, get everything nice and straight. I laid out the first bend, and I'm not going to just rush in and do all the bending because all of these bends need to land in exactly the right place and the right distance apart, which is kind of difficult to do, at least for me in sheet metal. So I'm going to make this first bend, and I'm going to use it to kind of calibrate my machine and my process. I'm going to line up the die on my little V-style bending brake, and I'm going to press the bend right on that line. That will allow me to then measure where that bend actually ended up relative to where my line was. And since I know exactly how far my line was from that end, I can measure both the inside and the outside of the bend and find out what my bender is going to do if I put the bending die right on the line. The results from this test were actually really cool. The outside dimension is exactly 2 inches where my line was plus the thickness of the material, and the inside of the bend is exactly 2 inches. So that tells me that this bender puts the entire bend on the outside of the line, which is actually not what I would have expected. I would have thought it would split the difference on that line, but it doesn't. But now I can do the rest of them with confidence. However, already I've got a problem. I was planning to do all of the bending with this machine, but some of the bends are too close together. The lower die is a little bit too wide on this machine. Despite this being the smallest brake that money can buy, it's just a little bit too big for some of these bends. Now, Kozo has a suggested tool for building these stairs, and I was trying to avoid making another custom tool, but it looks like I'm going to have to. He has a design in the book for this little bending jig that goes in your bench vise, and that allows you to get these tiny bends that are really close together. So I decided to go ahead and make this after all, and just like that, these little stairs became an entire video. Now I thought it might have been better to have the dies in the center of the jaws so that the jaws are kept balanced and are squeezing evenly. However, he's got them way out here on the edges of the jaws. I suspect that's probably for clearance, and I don't want to second guess his design, so I'm going to build it as he suggests. The scrap bin offered up these pieces of steel from which to make this machine, so let's get to it. One of my favorite things about these portable bandsaws that I think does not get enough press is how easy it is to change the blades. I use 2 blades, a 24 pitch for sheet metal, and I've got the coarsest one you can buy, the 14/6 TPI blade, which I use for cutting heavy bar stock. And really, how easy it is to change these blades means that you're never using the wrong blade. With the big bandsaws, changing the blades is often a project in itself, and it messes up the tracking and the tension and all this stuff. With these little saws, the blade just whips right off. It's a single big plastic lever. Tracking and tension and everything is all preset, and you don't mess up any of it by swapping the blade. Really super, super easy. And since someone always asks, no, I'm not going to tell you about that wall mount for this bandsaw, I'm sorry. It is a prototype that was sent to me by a manufacturer, and they asked me not to talk about it, so I'm sorry, I can't tell you what it is. However, Swag Off-Road makes very similar products, so if you want a wall mount for your bandsaw, which I do recommend, check out Swag Off-Road. #not sponsored. The tool consists of two pieces for the die, the V shape and the pointy bit. Those are technical terms. I'm going to make them both together. I'm going to machine them down to dimension from this piece of bar stock so that I know for sure that both halves of the die are the same dimension. Ultimate precision is not that critical for a bending die. We're talking about bending sheet metal, which is a pretty low precision activity anyway, but you know, the nicer you make the dies, the better they're probably going to perform. Now, I've shown you squaring up stock so many times on this channel, I'm not going to go through the details again, and frankly you're probably bored of hearing me talk about it. So while I do this, I offer you an alternate viewing option in the lower left, which is sprocket spinning on an office chair. You were wondering how long I was going to do that, weren't you? With that stock squared up to dimension, I then split off a small chunk of it, which will act as the V block, and the larger piece will act as the pointy bit. I squared up both ends of both pieces. For holding the really little piece, it helps to put the other piece at the other end of the vice jaw to balance that vice jaw. That ensures you get a really sturdy grip on that tiny little piece that's right at the edge like that. Now I can cut the V groove in the small piece. I'm going to set it up at 45 degrees and I'm going to cut this V with the end of an end mill. Normally when you want to center a V groove in a piece using an end mill this way, there's a bunch of math involved in order to ensure that it ends up centered. I actually covered that in my cross drilling fixture, so check out my projects playlists for that to see exactly how that's done. However, in this case, it's really easy because I want the V to fill the entire side of the piece. So all I had to do was blue up the piece and then come in from the side very, very slowly until there was just a wisp of blue on that top corner. And then I can just mill down from here in multiple passes until there's just a wisp of blue on the bottom corner. And that's going to be accurate enough for this. Essentially, the distance between the edges of the V on both sides of this face is 0. So that makes it really easy. Just start at 0, end at 0 on both sides, and you're going to end up with the V perfectly centered on this face. Especially eagle-eyed viewers may have noticed that the drawing actually specifies an 85-degree angle for these Vs, not a 90, which is what I'm going to end up with. Now, an 85-degree angle is a good idea for a tool like this because it ensures that you can get a full 90-degree bend out of it. That 5 degrees accounts for spring back in the material. You want to bend it a little bit sharper than 90. However, I'm going to be bending brass with this, which has very little spring back, and I actually don't need 90-degree bends from this particular tool. And cutting a 90-degree angle is a whole lot easier than cutting an 85-degree angle. 5 degrees easier, in fact. So since I have an actual bending brick for 99% of use cases, I think this will be fine. There's my little groove, looking very V-ish. However, there is a catch with this, as with any V-groove type fixture that you make. You can see that while this fits extremely nicely on this 1-2-3 block, that 1-2-3 block has chamfered corners on it. And that makes a difference. Normally, when you make a V fixture like this, you want to do an undercut along the base of that V. Here's a regular commercial V block, so you can see what I mean. You can see how there's a slit that's cut right down the center. That does two things. One, it's clearance for the surface grinder wheel, but also it allows you to put things that are truly 90 degrees into that V and have them sit firmly all the way down in the V. You cannot do this if you don't cut that undercut, because otherwise there's a little bit of a fillet in that inside corner from the end mill. There's no such thing as a 0 corner radius end mill, so there's always going to be a fillet that prevents perfectly square things from seating all the way down in there. If your V fixture is for round things, it doesn't matter. In my case, it's just a bending brake, so I also don't think it's going to matter. For what it's worth, my commercial bending brake, as you can see here, does actually have that clearance groove in the bottom. How necessary that is for bending, I don't really know, but because this bending tool is so small, I don't really have a slitting saw that small. I could do it with a fret saw, I suppose, but I'm going to leave it and we'll see how it does. I can always add the clearance groove if necessary. Now for the pointy bit, I need a center line on this thing. I'm going to do that on the surface plate since that's easy. I just set the height gauge to half the height of this piece, mark my center line, And then I can go over and set it up on the mill at a 45-degree angle using a simple angle block. And then I just have to mill down to that center line in both directions, and I'll have my 45-degree angle, and it'll be nicely centered on the piece. Milling down to the line will get the piece centered to, within probably a few thousandths, and that's plenty accurate enough for this. If this was some sort of an indicating or metrology fixture where that peak had to be as accurately centered as possible on the piece, you'd want to use different methods for this, but in this case, milling down to the line, and in fact, milling the same amount off both sides ensures that the peak ends up very, very close to center. That completes the two pieces of the die. They're looking very press brake die-ish. Pretty pleased with those. You can see that they don't seat fully tightly together, of course, because again, that undercut is missing in the V piece, but I think this might just work. Enter stage left, the flat bar, to make a way to attach those dies to my vice jaws. I wasn't sure if I wanted this plate to attach in place of the vice jaws or on top of them. So let's get these jaws off of the vice and take a look. I've never taken these jaws off before, in fact. Turns out there's a step on the casting, and that's going to interfere with the clearances that I want around this bending die. So I'm going to put the jaws back on, and my dies are going to mount on top of the jaws. I'll use one of the jaws as a template, however, to scribe the length of the piece that I need to cut, and I will also transfer punch these holes while I'm here. This piece is all pretty low precision. We can use very basic fabrication methods to make these parts. And since I need two identical ones, I'm marking and scribing one of them, and then I cut the other one to length matching that, and I will drill them together. I could of course drill these holes on the milling machine, but I do love any excuse to use my float lock vise on the drill press. So if I don't need ultimate precision, if fabrication level precision is enough, then that's what I'm going to do. I line up on my transfer punches, lock down that float lock vise, then I'll center drill that, and then drill it straight through with the clearance hole for the bolts that were in the vice jaws. The float lock vise is really great for this type of operation because it's a trivial matter now to unlock it, swing the vise over to the other set of holes, and drill those. Quick deburr, and I think we should be there. Now the next thing I need to do is figure out what those bolts actually are that are holding the jaws on. So I went to my thread checker and determined that they are M6-1, which is not at all surprising. M6 is the 1/4-20 of the metric world. I don't have nice cap screws like that in M6, but I do have a bunch of hex bolts, so I think these will probably work. I don't want to drive to the hardware store just to have slightly more posh hardware. I'm going to bolt everything up now because this is A, going to tell me if I got the holes in the right place. It'd be good to know that now. And B, because this is going to be the fixture for attaching the dies to these plates. Kozo suggests silver soldering them, but since everything's mild steel, I think welding them is just going to be easier. My welder won't reach the vise, so I got to bring the vise over to the welding table. This will be the world's easiest welding setup because, of course, the vise can hold them perfectly in place while I weld them. As long as I'm careful to make sure everything is square and straight and well aligned and so on, all I have to do then is snug up the vise a little bit, and that's going to hold everything perfectly straight while I weld. Making sure everything is nice and square because of course I want the bends that this die produces to be square. And then also checking the gap above and below, make sure the dies are nice and evenly aligned. That all looks really good. So let's weld them on. I'm putting simple tacks, one on each side of both dies. They really don't need more than that, and these are very small pieces. I don't want to risk burning through them. I also don't want to risk the heat of the weld pulling the dies out of alignment, which would be very likely. If I went in there balls out and laid down a thick bead on one side, those dies would almost certainly no longer align when I was done. After the first tacks on one side, it looks like everything has stayed straight, so that's good news. I'll put some tacks on the other side now. There's no appreciable lateral forces on these dies, and the ends of the dies are square, so when the vise is squeezing the dies together, there's really nothing that's going to want to cause the dies to deflect laterally. The tacks are essentially just holding them in place on the vise jaw so that you don't have to hold them with your hands. which you could actually do, by the way. I've done that with similar types of dies and form bending tools in a vise. If you just hold everything carefully with your hand and squeeze things together and line it up and then squeeze it all the way, because there's no lateral forces on anything, they don't actually have to be attached to the jaws. However, it is very fiddly if they're not, and it's certainly a lot easier to have things permanent like this. The dies now look like they align really well. That's looking really good, nothing moved. However, this low-budget fabricator's vise has a lot of play in the jaws, and I don't love that. That might interfere with the function of the jaws. So I'm just going to shim the slide on the vise. A little bit of trial and error determined that about 25 thousandths of shim stock is enough to snug up this jaw so it doesn't wiggle around quite so much. That should work just fine. All right, moment of truth. I've got a piece of scrap the same thickness as what I want to bend. Let's see how it performs. I'll line it up, squeezy squeeze. Ooh, that's very satisfying, isn't it? Bending dies are extremely pleasing. That seems to have done a nice job. Looks like I got a really nice 90-degree bend, even though my jaws are 90 degrees instead of 85, so I think I got away with that. If this had been steel, I probably wouldn't have. The spring back would have been more, so I probably would have needed to do the 85-degree jaws, but that seems to have worked just fine. But now, the real reason that we're here, this problem that this tool needs to solve, is can I put two bends extremely close together? That's, of course, what my commercial machine cannot do. All right, I'll put it all the way up like this, and we'll see how close together these bends can be. That's two 90-degree bends, and it seems to have worked just fine. It looks like the bends are just over 200 thousandths apart. And that's actually perfect because the two closest bends on this staircase are 200 thousandths apart. I could get them a little bit tighter still by doing some filing and cleanup on the outside of that jaw. My tack weld is costing me a little bit of clearance there, but I think it's okay. However, I did notice that the die's making some marks on the material that I didn't love. I think my edges are a little bit sharp there. And while I was doing this, actually I noticed that the weld blew through the sharp edge of that die on one side. So yeah, I got a little carried away with the tacks on the inside, but I don't think that'll cause any issues. So I just rounded off the very edges of those dies so that they aren't gouging into the brass as it pushes the material in. A couple more rounds of test bending and smoothing out the jaws, and that seems like it's done the job. There's still some marks, but they're not gouges anymore. They're just surface scratches, which honestly my commercial bender does too. All right, 12 minutes of video time later, and we're back to where we started. Let's see if I can do the second bend now on this piece that I couldn't do at the very beginning of this video. And well, no I can't. I quickly realized that there's a flaw in my scheme, which is that the throat depth on this tool is not enough. I don't have the reach to get these bends far enough. Even if I flip it around to the high clearance side, the short bend on the other side is still too long. I need a lot more throat depth. After going back to Kozo's drawing to figure out why this works for him and not me, I realized the issue. He thinks you have a very small vise. Now, there aren't actually any dimensions on anything except for the width of those dies. However, Kozo's drawings are all to scale, so I measured the length of the pointy bit, and that's how long I made mine. However, I didn't notice that his vise is very, very small, and my vise is an 8-inch vise. It's a big North American vise. So the bending tool needs to have a much deeper throat in order to have the clearance on the left edges of the jaws for the material to clear. However, I was naughty this year, so during the night, Metallicor, the god of machining, and his busy little elves visited, and when I came out into the shop in the morning, the bending dies were magically longer. But also his elves peed everywhere. It's kind of a mixed bag. That extra length is the secret sauce that this tool needed, however. Now I can do that bend really close to the other bend, and that long material can stick out. Everything clears, and I can get the angle needed. Looking really good. Well, except for the fact that here I am on bend number 2 of 21, and I've already scrapped the part. I was making an educated guess on how high the risers need to be. I actually measured them off of Kozo's drawing because he doesn't specify the height of the risers. And well, now I know why, because he doesn't know exactly where the slope on your tender is going to land. So it's better to do a test like this and actually measure how high the riser needs to be. So fortunately, I made a spare piece, and this will be my practice, and I can use it to measure the proper height of the risers. Now that I know the riser height and I know exactly how these two tools bend relative to where the lines are, I can now safely lay out all the bends all at once. And then I quickly realized I need those lines on both sides, or at least Some of the lines have to be on the other side. Rather than risking my smooth brain trying to figure out which lines need to be on which side, I used the surface plate and transferred all of them to both sides. Then I don't have to think about it. After the first riser bend on the new piece, I double checked to make sure that my height was correct, and that is actually looking really good. The test is whether the riser ends up level when it's sitting in the final position, and boy, that's really, really good. It's darn near perfect. Now let's see if I can do the other 20 bends without screwing any of them up. There's 7 of these stairs, and each stair has 3 bends in it. There's the bend that goes from the tread to the riser, and then from the riser there's a little 17-degree, very short angled section where the mounting bolts actually go. That's the tricky bit. That's the bit that requires the special tool. The other 2 bends for each tread I determined that I can do on my bending brake with a little bit of judicious flipping of the piece around for clearance and so on. Here's the first tread bend, and then there's the transition from the riser to the very short mounting area, the 17-degree section, and then just past that goes from the 17 degrees to the next tread, and then down for the next riser and so on. So that little flat angled area between each pair of tread and riser is really the tricky bit. That little mounting bolt area at 17 degrees is only 200 thousandths wide, just wide enough for the heads of some number 0 screws. That's really where this special Kozo tool comes in. I also made use of a toolmaker's vise to make fine adjustments to each bend. A toolmaker's vise has really nice, clean, precision jaws, so it's easy to line up and massage a bend a little bit one way or another to get the angles just right to make sure that everything lands properly. I'm not going to claim that every stair tread is perfectly level, but they're all within 2 degrees of level, let's say that. My risers are just a tiny bit too tall, but I was happy enough with that. I wasn't going to redo the whole thing at this point. I left myself extra material at the far end just in case, and now I can cut that off with the fret saw and then file that end nice and square. Now for the mounting holes, I set my dividers to half the width of those tiny little 17-degree areas I was talking about, and I use these to scribe horizontal center lines on those mounting bolt areas. Then from here I can clamp it in the vise on the mill because of course those 17-degree areas all are in the same plane because they have to be or they wouldn't mount on the tender, and I can center it up on the edge finder for the y-axis, then use my pointer to line up each pair of bolt holes on the x-axis. It would be nice if they were all magically the perfect distance apart on the x-axis, but of course this is folded sheet metal, so they're not going to be perfect. I lined up each pair one by one, drilled them out, and then countersunk them by hand for teeny tiny number 0 flathead screws. Those are nice and flush. That's going to look nice. Well, a little bit of cleanup, and here is the final staircase. It wants to slide off of there until it's mounted, so I'll do my best to balance it on there for you, give you the idea. I don't want to mount it to the back of the tender yet because there's also a handrail that I need to make, and I want to kind of have them both in hand and make sure everything's lined up before I mount everything. So for now, we're going to stop here and call it a flight of stairs. I'm really pleased with that. This was going to be a difficult piece, I knew, and it was. Bending sheet metal and doing it accurately and having lots and lots of bends all end up the right distance apart, that is something that keeps me up at night. If I'm ever in some situation where saving the world depends on me personally getting 2 sheet metal bends the exact right distance apart, well, sorry world, we had a good run, but I'm not your hero. That's going to look really nice when it's all painted up with the tender, I think. And well, I hope you enjoyed watching me make this little staircase. Thank you very much for watching, and thanks especially to my patrons who keep all of this content flowing like the rivers of Babylon. What? What are you reading? Stop it. Thanks for watching.